Hello friends, in this lecture we're going to implement the player's movement code. First of all, let me quickly explain how this is going to work and then we're going to switch over to Unreal to implement it. First of all, we are trying to move the player in one of 8 directions: up, down, left, right, or diagonally in these 4 directions. So a total of 8 directions. And in the tick function, we need to decide the next position the player needs to be in if the player is moving, if one of the keys we bound in the last lecture is being pressed. So for example, if we're pressing the D key, that means we need to go right, so we need to calculate how much we need to move the player, and we need to calculate that new location that the player needs to be at. And after we calculate that, we're simply going to call set actor location and move the player. That's the basic idea, and the calculation we need to make is going to require a number of variables that we need to create in the player class. The first one is going to be the movement direction. This is going to determine which way we go, and we saw in the last lecture that we can get this from the input system. So this will come from the input action move. We're going to multiply this with the movement speed, which is going to be another variable that we're going to create. Movement speed is going to control how fast the player is moving. So the movement direction here is not going to control how big this number is. It's simply going to be 1 or -1 in X or Y. So it's only going to control whether or not the resulting number is positive or negative, which is going to determine the direction. And like I said, this will control how fast the player is going. And finally, we're also going to use the delta time here so that this movement is frame rate independent. This is going to give us the distance to move. So that distance I just showed you that the player needs to move to be in the next location. So like I said, we're going to take this distance to move and we're going to add this to the current location of the player, and that's going to give us the new location. But we should also consider the fact that the player shouldn't leave the limits of the map. So we're also going to check before we actually use this new location if it is outside of the limits of the map, and if it is, we're not going to make that movement. So that's basically how the movement is going to work. Now let's switch over to Unreal to implement this. So first of all, inside of the player character.h, we're going to create those variables that I was just talking about. So these are going to be, first of all, an edit anywhere float called the movement speed. Let's set this to be 100 by default. And then we can adjust this from the editor because we're making it edit anywhere. The next one is going to be the movement direction, and this is going to be visible anywhere because we don't want anyone to change this. This is going to be set from the input, so no one should be changing this. And this is going to be an F vector 2D movement direction. And after this, we're going to create 2 more F vector 2D variables, and these are going to be the horizontal limits and then the vertical limits. And these are going to make sure that the player doesn't leave the map, or the game area, not the map. Okay, so these are the variables we need. Now let's go into the CPP file and start working with these. The player is going to move inside of the tick function, but before we do that stuff, we first need to get the movement direction from these functions that we bound to the move action. So the move action has that value we saw in the debug information, that vector 2 with the x and y value. We can get that inside of these functions from this value argument that Unreal is passing us. To do that, we're simply going to say value.get, and then we're going to type in the type of this value, which is an F vector 2D. And then we're going to set this directly equal to the movement direction. Just like that. So this is going to make it so that when we press the D key, the movement direction is going to be 1 and 0. When we press the W key, it's going to be 0 and 1. And let's say we press A and S at the same time, it's going to be -1, -1. We're basically setting movement direction equal to that value, and that's going to give us the correct direction we need to move in. And here, when the movement is complete, we're simply going to set this to f vector 2d 0, 0, so that the movement doesn't work anymore. Because in this multiplication here, if you multiply with 0, of course the result is also going to be 0, and the player isn't going to move anymore, which is what we want if the movement is over, if we're not pressing any one of the keys anymore. So now that we have the direction, we can start implementing the movement here in Tix. Before we can move though, we first need to check if any one of the keys are currently being pressed or not. And to check that, we can simply check the length of the movement direction vector. So we can say movement direction dot length. If this is greater than 0, that means one of the keys are being pressed. So for example, if D is pressed, the length is obviously going to be 1. If W is pressed, it's going to be 1. So if any one of the keys are pressed, it's going to be 1. So like I said, we can use that logic here to move the player or check before moving the player, because if none of the keys are pressed, there's no point moving. But there's a important case here that we need to check. And that's the case where two keys are being pressed at the same time, because we're going to use the movement direction in the calculation. So because we're going to use it here. So let's say that only one of the keys are pressed. That would be like this, a vector like this. And that would have a length of 1. Or if we're pressing W, let's say, it would be like that. But if we're pressing both at the same time, then the resulting length of that vector is going to be like that, which is going to be more than 1. It's going to be like 1.4 or √2. So this is going to, be applied in this calculation, and it's going to make us go faster diagonally compared to going up, down, left, or right. So because of that, we actually want to normalize the movement direction vector here if we're pressing two keys at the same time. Okay, so let's see how we're going to fix that. We're going to check if the length here is greater than 1. If that's the case, that means we're pressing down two keys at the same time, and we're simply going to call movement direction.normalize. And normalize is going to basically make the length of this vector equal to 1. So that's going to fix that problem. Next up, we're going to calculate the distance to move, this value right here. And you can see the formula for that right here. We're going to take the movement direction. So let's actually create a vector 2 here. Vector 2d, distance to move. And this will be movement direction multiplied by the movement speed multiplied by the delta time. And we're getting the delta time here as an argument to Tix. And like I said, that's going to make it so that we're going to move at the same speed even at different frame rates. And now that we know how much distance we need to cover, we can actually calculate the new location of the player. And the new location is going to be an f vector instead of an f vector 2D, because as you know, the engine is working in 3D, even though we're making a 2D game. So when we're making changes to the location of the actors, we actually need to, start working in 3D. So this will be the new location. And the new location is simply going to be the current location, which we can get by calling getActorLocation, plus the distance to move. But of course, we can't just add distance to move like this, because distance to move is a vector 2, but this is a vector 3. So we're going to create a vector 3 here. And we're going to use distance to move.x and distance to move.y like that. And you can see that I did not use the Y position here because the game is taking place in X and Z. So we're not using Y. So that's an important thing to realize here. We're taking the distance to move .y, which is the vertical movement that we need to make, and we're applying that to the Z position. Okay, so at this point, this would work. If we recompile the game, we're going to be able to go, we're going to be able to make the player move. But like I told you in the presentation, we need to make sure that the player doesn't leave the game area. So in order to implement that, we're going to do this addition here in 2 steps. We're going to make the player move, we're going to make the player move horizontally, and then we're going to check if the player has left the game area or not. If yes, we're going to take that movement back. And then we're going to do the same thing vertically. We're going to move the player vertically, check if they left the game area or not, and if they did, we're going to take that movement back. So that's basically how we're going to do this. And in order to make that work, we're going to create 2 functions. So here in the header, down here, we're going to create 2 functions that return booleans, and these will be is in map bounds horizontal. This is going to take in the X position, and then we're going to create is in map bounds vertical, and this will take in the Z position. Let's create the function bodies for these down here. Paste in the class names as well. These are going to return a boolean, so let's create a result boolean, and we'll set this to be true by default, and at the end of the function we'll just return this. Let's do the same thing here, and in the middle we're going to check if the X position that we provided to this function is inside of the map limits, and we created the map limits variables here. So let's actually set these in begin play. And for them, currently I'm just going to say horizontal limits f vector 2d, and we'll make these, let's see, negative 640, positive 640 for X, for the horizontal limits, and for vertical, we'll say negative 360 and positive 360. In the future, we're going to calculate this based on the size of the camera, but just for now, we're going to use these hard-coded values. Okay. Now here we're going to check, is the X position here greater than horizontal limits.x, and is the X position less than horizontal limits.y. So if this returns true, that means, let's see, if this returns true, that means, let's say these are the horizontal limits, the player is somewhere in here, let's say here. If it returns false, the player is outside of these limits. And we're going to do the same check for vertical. We're going to check for these vertical limits and check if the Z position is inside here. And here we were checking the X position. So let's copy and paste this. And this time we're simply going to check for the Z position here, and we're going to check with the vertical limits. Okay, now we're going to turn this into a 2-step process like I was saying. So we're going to first calculate the horizontal movement. So I'm going to take out this Z movement here and say 0 instead of that. Then we're going to check. So we're going to check if we are in map bounds horizontally, and we'll give the new location dot x to this. And let's see. If this returns false, so if we're not in map bounds, we're going to take this movement back. So we'll say new location minus equals this. And next up, we're going to do the same thing vertically. So we're going to copy and paste this bit we're going to get rid of this get actor location, and we're going to say plus equals, this time, the Z movement, the vertical movement, that's going to be dot Y. And this time we're going to check if is in map bounds vertical, and we're going to pass the Z position of the new location. And if this returns false, we're going to take this movement back. So we'll say 0 there, and we're going to say distance to move dot Y here. And after we do these, we can finally call set actor location. I didn't even realize we weren't calling this. So yeah, at the end, we should call this with the new location so that we actually move the player. So this should be all we need to move the player. We have the movement direction that we need. We're getting that from the input system. We're checking here if any of the keys are being pressed. And if both keys are being pressed, we're normalizing the movement direction so that we don't go faster diagonally. After that, we're calculating the distance to move, which is the movement direction multiplied by the speed multiplied by delta time. That's going to tell us how much we need to move in what direction. This is a vector too. After that, we're getting the new location. We're calculating that by taking the current location of the player, and firstly, we're adding the horizontal movement. After we do that, we check if the player is in map bounds. If not, we take that movement back here. And after that, we do the vertical movement. We add the vertical movement to the new location. We check again if we're inside of the vertical bounds. If not, we also take that movement back. And finally, we set the new location as the new location of the player. Hopefully that's all clear. Let's go ahead and exit out of Unreal. Rebuild the game. And then we're going to test this. Okay, now we can go ahead and actually test this. So let's play the game. And when I press W, A, S, and D, you can see that we can make the player move. He's a little bit slow, so we probably should increase the movement speed. And I also think he's looking a little funny, and I'm suspecting that is because of the anti-aliasing method. So we're gonna switch this over to be FXAA, and we're going to play the game again. And yeah, that fixes it. Okay. Let's go into the player blueprint. Let's go down to the variables we created, and here we're going to set the movement speed to be something like, I don't know, 400. Play the game again. Yeah, this feels much nicer. And you can see that now we can make the player move. And the map limits should also be working. As you can see, when I get to those map limits, which are invisible in this case, I can't go beyond them. And let's make sure they work in all dimensions. And we can also make sure that the limits are correct by changing the camera's width to be 1280, because that should give us a 1280 game area, which is going to have negative 640 the left limit and 640 the right limit, and 360 up and down, which is the hard-coded values we set in Begin Play right here. I did these based on that camera width, but in the future we're going to actually get the camera's width and calculate these limits based on that. But for now, we're just going to have these hard-coded values. So let's try this again. And you will see that in this map size, the player is exactly at the edge. I want the player to be able to go beyond the limit just a little bit, because I don't think it would look nice if we were stuck here, for example. So I want there to be a little bit of a margin, just like that. Great, so that's going to be all for this lecture. Now we have a top-down player that can move in all 8 directions, and he's obeying the game area size that we're setting. Thank you for watching. I'll see you in the next video.